I'd like to take a few minutes to welcome everyone to the second part in the Dramm Everything webinar series. Today we'll be talking about filtering your irrigation water to reduce shrink. I'm Karen Varga and I'll be your moderator over the next hour. Water is the single most important input when growing our plants, but water is much more than hydrogen and oxygen. It often carries components that we don't want in our irrigation systems. To remove particulate and other solids, filtration is the first step. Proper filtration can reduce mechanical issues and even help manage pathogen load. This webinar will discuss the basics of filtration with a look at the different types of filters available. Now, our expert speaker today is Les Evans from Dramm Water. Les has been in the greenhouse industry since 1995 after getting his degree in water and soil and environmental engineering at North Carolina State University. He spends his days at Dramm helping growers navigate through to the best water treatment decisions for their facilities, as well as overseeing the engineering and project management of soil treatment projects around the world. As you have questions for Les about the presentation or irrigation-related questions, you can send them to us via the questions box in your control panel, and we'll have a few minutes at the end to answer them during our Q&A session. Les, again, I'd like to welcome you to today's webinar, and you're welcome to start your presentation.
Great, thanks, Karen. Really appreciate it. In case anybody that's tuning in now wasn't there, I will be mentioning the past presentation as well as the one coming after this. I'm the middle one of three. And in case you missed it, just a quick blurb on Dramm. I've been around for a while, obviously. I think we're at 77 or 78 this year. But if you're not familiar with them, then obviously visit our website and you can see what else we do. About 8 years ago, we sort of created this dedicated team that focuses exclusively on the total water management and treatment for essentially CEA, controlled environment ag. That's everything from looking at your source water to pumping it, filtering it, of course, which we'll talk today, enhancing the water as needed, nutrient management and injection, and then what Kurt talked about in the first webinar, which is available online now, irrigation systems. So we're pretty well known for drip irrigation, misting, almost anything, how to get your water. And of course, we invented the water breaker, so hand watering as well, not to be forgotten, the trusty hose. So again, that recording is available online, hosted by our hosts at the magazine. Today, as Karen mentioned, I'll be talking about filtering the water to reduce shrink. It could be titled a million different things, but ultimately, let's choose the right filtration system for our facility and one that's going to make us more profitable. And understanding everything that goes into that. On July 24th, I want to point out that my colleague, Al and I run the water division at Dramm, and Al's going to really get in depth on, we'll call it water treatment considerations for improved profit. So there's sort of physical filtration that I discuss, and then he's going to get more into a overall and chemical treatment aspects. And so that's going to be a really good one, tying a lot of what I talk about together with the total package. So today's objectives, what are we going to discuss? It will be, let's make sure we understand what it costs us when we do not adequately filter our water. So there's a slide about what that really costs us. And then conversely, of course, what are the benefits of doing a good job and making sure that we're filtering the water as we should be for the crop we're growing, for the facility that we're in. The meat of the presentation are the next two: filtration design considerations, what we need to look at when we're choosing that either retrofitted filter or a filter for a brand new facility. And we'll get into the basics of what kinds of filters are out there and what they are good for and what they are not good for. So here's that slide. Obviously, the title of the talk today is, it costs you production if you do not filter your water correctly. Like Karen said, there is a lot in water. It isn't just hydrogens and oxygens. It's carrying a lot of things we may want and a lot that we may not want. If we are not providing good filtration, we are going to not create 100% crop with 100% health. That is our goal. So it can cost us extra labor. The obvious one is we're going around and we're maintaining equipment because we haven't filtered out stuff that is clogging our emitters, our drippers. We're having to replace them and go around and put eyeballs on things that we might not should have to do if we've properly filtered. People don't think about these next two: higher fertilizer use and higher chemical costs. If we haven't filtered the water, if we haven't removed those things that aren't doing us any good, we might think that the plant nutrition is failing, and a lot of folks throw more nutrients into their mix to try to make up for the fact that they haven't actually cleaned the water well enough. And on the other flip side, they might be injecting chemicals, sanitizers, such as our activated peroxygens and chlorines and chlorine derivatives, and spending a lot of money on chemicals trying to clean up the water when all we needed to do was make sure we invested in a proper filter, and that makes everything much more efficient when we're injecting our sanitizers. And again, the shrink at retail, if we're selling into a garden center or a grocery store chain and that product just isn't what it should be, and isn't lasting as long. Reduce product grade, value, price, weight, depending on what sort of flowering or fruiting crop. If that's how we're paid, we want to make sure that we're getting the best bang for our investment. If we aren't filtering right, that just isn't going to go as well as it should. And it might not present itself until we've put it onto that retail shelf, so to speak. And so that just turns into just all of these things that add up to the costs of not filtering appropriately. So let's get into some positives. The benefits of good filtration. It's certainly almost always the first step towards pathogen removal. We want to make sure that we are taking those steps to clean the water so that if we do need a sanitizer, oxidizers to chemically remove and destroy pathogens, that we've got good filtration. It is going to be a huge benefit to help us do that efficiently. Reducing the overall demand of those, again, chemical or other types of sanitation systems. It's going to increase their value and their efficacy. Right in line with that, reduce chemical costs. I've talked about that. And then the labor, reduced labor going around. The numbers are staggering. The facilities I've seen, it just gets ahead of them, and years go by, and it's just a huge cost where one or two employees at a small nursery are just spending most of their hours trying to keep things unclogged and replacing things that they shouldn't be needing to. And of course, the bottom line is we want to grow a healthy, profitable plant, whether or not we're selling that plant or the fruit of that plant's labors. We want to make sure that we've done everything we can to increase its health. And again, my little statement is a healthy plant is a profitable plant. So this next, I just throw this out here. I'm going to give some shout outs to years worth of research, and there'll be a slide at the end of the presentation where just some good resources on the research side can be found. But this was fascinating. From 40 years ago, I was 7 years old when this came out, but it's just something that's fun. I mean, if you're irrigating with low quality water, the combined issues, physical, chemical, and microbial, those variables can result in emitter and filter clogging and promote biofilm formation on our surfaces within the water distribution systems. Originally in 1979 and then in 97 updated. I thought that was really great, and here we are 21 years later talking about the same thing. Technology has gotten way better, but it is still, we're still tackling the same issues we were 40, 50 years ago. I highlighted biofilm. We're going to talk about that a little more in depth. Al will also talk about it. We feel we're doing a disservice to our audience and our customers if we really don't bring up the biofilm issue. It's been published about a lot recently, the last 5, 6, 7 years, but I want to make sure we talk about that, so that's why that's highlighted. So getting into the meat of this presentation, I'm going to be talking about considerations we need to be looking at when it comes to choosing the right filter, right? These are what I talk to folks all day, every day about. We're going to discuss the source. We're going to talk about flow rates. How much water will you need to filter? That is, when we start talking dollar signs, it's because we have low flow rates, medium flow rates, or high flow rates, and there's going to be an appropriate way to tackle that. I'll ask for a peak gallons per minute, a peak GPM, when everything's on and you've got to irrigate those 5 veggie towers or those 5 poinsettia zones, or whatever you're irrigating. I need to do 5 at a time. How many gallons a minute is that? And then what's that whole facility use per day? So I've got to look at those 2 critical flow rate numbers to understand how we're going to take our next steps. Storage is our friend. If we have the availability to store water, we can start saving money right from the beginning of this discussion. Tanks are cheap if we have the location to put them in, but they are going to help us reduce the size of filters and therefore water treatment. If I can store water, I want to be able to treat something 24 hours a day slowly, a lot more efficient than trying to treat it quickly on demand at the worst case scenario all the time. So storage is something that's just hand in hand with any good filter or water treatment system that we're designing for somebody. We really want to see if there's storage available. That's going to really help things pay for itself quickly. Target particle size, we're going to do a quick slide on. Let's make sure we understand what we're looking at, a lot about what's in the water. And so what are we targeting? If we don't need to filter down to a tiny particle, then let's not spend what will probably be more money for a filter that can do that, if we really just need to be removing particles from the medium or larger size. Seasonality, this one sneaks up on folks, and something that I've learned to ask from the very beginning. I apologize, there's a dog in the background there. Does the demand change seasonally? Do we need more water in the summer months if we're an indoor operation? Probably not. But if we are in a greenhouse or nursery, then certainly that might be the case. And quality, does our quality change? I work with a lot of folks that are storing their water in a pond. Doesn't necessarily need to be a tank. Maybe we have pond or ponds, but that will change seasonally, especially if you're somewhere where it gets hot and cold. I'm in North Carolina, and we have 4 pretty distinct seasons here. That pond's going to look a lot different in the winter than it does in the summer. So does our quality change seasonally? Water temperatures. This is a big one. I just put the reverse osmosis. We'll get into that in a bit, but boy, it can really greatly affect the efficiency of a filter you're looking at. RO is the biggest culprit there. But the pond water, of course, if it's a surface area. So that is something we really want to talk about. Continuing with the same list here, obviously water quality and chemistry. That's very obvious, but we need to really understand what's in the water. What do we like in there? What don't we like? What is its chemistry? We'll talk about that in a little bit more depth. This is a tricky one. I'm an engineer, but if we are retrofitting a filter or anything in line to an existing system, time and time again, we'll get a call after someone's bought something off the shelf and tried to stick it in, and it just didn't. It made everything downstream from that work a lot less efficiently, and that's what we would call it's increased the pressure drop and not allowed things to work the way they should. So we have to consider that. Backwashing or not backwashing. We'll get into each filter and talk about. We almost always want an auto or easily backwashed filter. Some that's not a potential, it doesn't need to be backwashed. Others, you have to be very good about backwashing, and some use a lot of backwash water relative to its process. So in certain states, it's actually illegal to backwash your water into the drain. Well, what do you do with that? Lots of customers have to truck it off. That's an expense. So again, these are things we need to consider when we're looking at what type of filter what's its efficiency, and what's the backwashing like? Do we have to how much water are we going to have every day, week, month, year that we have to do something with. We're going to talk about where that filter should go. Is it a centralized or distributed system? Do we just have one big group of filters in the middle of my facility? Or do we have that plus zone filters or only zone filters? We see people come to us that have one or the other, and a lot of times, and almost always from scratch, we would recommend both depending on the facility, but there's almost always two sets of filters at least in a small, medium, or large facility. And then obviously what needs to be filtered out. We'll get into the details here in a little bit, but these are the sort of the four terms that we use. We've got four flavors of things we want out of our water usually. And again, there'll be a whole slide on that. So, and then do I hope to grow and expand in the future? Let's look at that. Are the filters modular? Can I add another set, a third, a fourth filter easily as I grow, as I add more plants to my growing facility? So source and flow, I'll talk quickly about this. I don't have a photo of the municipal water, but we've got a well, a pond, and then just a pump set there just to represent those things that I really already talked about. With well water, we can have, typically pretty stable, but lots of wells. People with well water come to us when things start getting weird because aquifers have dried down, and that happens more and more these days, depending on where you are in the world. We have seen wells with high sediments. We've actually seen wells with really bad pathogens in them because of years of runoff from nearby farms. High salts, high iron, and hydrogen sulfide are really the top three culprits we would see in a well. Let's make sure that well, we're not overtaxing it. What's its, flow rates, etc. So we got to consider our source. In the pond, I think I've talked about that enough, really. Al can get into that more. We can pre-treat a pond if that's going to be a source of water. We'll want to look at biologically treating that, aerating it appropriately, keeping it as good as we possibly can. But ultimately, Mother Nature's in charge there with a pond source. The temperatures can change. It can change immediately with a rainfall, things like that. I'm just going to keep throwing out storage throughout all of these things. And my notes to myself are, continue to talk about storage. It's going to pay for itself very, very quickly, no matter what we decide to do and what our source is. So let's get into a little bit of some tech here. We sort of break it down on my side of the desk into three things that could potentially be water quality issues. There's biological, chemical, and physical potential issues in our irrigation water from our source. Again, we could be creating them ourselves a lot of the times, but these are just some definitions of the three to give you an idea. Biological, obviously, things that are alive, pathogens, algae, and there's that biofilm again. I believe the next slide we'll talk about our friend biofilm. Chemical, high alkalinity, high salts, ECs, pH, even agrochemical runoff are issues that we tackle every day. Those will be considered chemical issues. And physical, this is really what filtration, we can handle physical, some chemical and some biological, but it's really starting with the physical, getting rid of particulates we don't like, and understanding total suspended solids in the water. So this is part of the techie lesson for the day, is total suspended solids are something that a researcher is going to ask, what is your TSS? So let's get that tested. Okay, let's understand where we're starting. Just to throw out some numbers, over 100 parts per million. Paul Fisher and his group at University of Florida, they sort of use that rule of thumb to say, you're just going to have issues, period. I don't care what you're growing or how you're growing, but over 100 parts per million or milligrams per liter of TSS, you're going to start having some issues. And we shoot for 20 or below parts per million of total suspended solids. So again, understanding these three potential quality issues and what filters are going to be applied and how they're going to take care of your potential issues. Here's our biofilm slides. I try to change them because I give presentations a lot. So does Al, and we just go Googling. Biofilm starts sticking in the pipes immediately. It starts sticking in everything very quickly. It's on our teeth. Biofilm is everywhere present where you have moisture. Essentially, it happens very quickly. And I love this slide. It basically just sort of recreates itself. And if we aren't filtering the water well, we're just exasperating the problem. We're making this problem happen faster. Number one, number two culprit of clogged emitters is a combination of basically sediment or particulates, I should say, in the water, plus biofilm is going to equal problems. And especially for micro irrigation, for misting, for drip irrigation, but even for just pumping large amounts of water, it really starts making our systems less efficient. And of course, it's carrying pathogens. It creates a really nasty matrix that things just start living and breeding in. And if we anger it, it just recreates itself faster. So it's tricky, but we've learned a lot in the last few years on how to handle that problem. It says mature biofilms continually contaminate their environment by arbitrarily releasing bacteria. I love that statement. I didn't give credit to wherever I found this. I can't remember where it's from, but I think that's a wonderful statement. And it just sort of scares us a little bit into taking action. Peter Conjoian, well-known grower and researcher, collaborator up in Connecticut, a brand new piece of pipe at the top that is clear water in the middle. And then of course, when we add nutrients and sunlight to our worlds or artificial lighting indoors and fertilizer, this happens. It's not if it happens, it's when it happens. So I just love a brand new squeaky clean pipe, very clean water in the middle creates a biofilm very quickly, and then we just exasperate it, add insult to injury by doing what we do in the industry and add nutrients to try to grow a crop. So biofilms always present. That's pre-filtration, filtration. We want to make sure we're taking care of that. Here's the slide. Just going to bring it all out here. These are the 4 potential things that we are taking care of in our water. Okay, these top 3 are really ones filtration can help tremendously with. So we have just the physical, obvious ones, sands and silts, inorganic materials, just stuff. That's our TSS. That's our total suspended solids. We have the organic matter. If it's a hydroponic recirculating system, if it's a one and done drip to drain system, these are still present depending on our source, but obviously in a recirculating system, we become much more aware of undissolved organic matter. How do we get rid of that? The dissolved inorganics, we're getting trickier as we go down the page here. These are our dissolved salts, irons, manganese, hardnesses, calcium carbonates. So filtration can tackle these very successfully for relatively low costs. Al will creep into the bottom one. That is the dissolved organics. Those are typically trickier to physically, mechanically filter out, but I want to make sure we understand what we're trying to filter out. Here's that slide I promised. I think hopefully we're all familiar with the ways we measure filters, but if not, this is some good filter 101. So mesh, as a reminder, is how many openings there are in a square inch of screen or media. So again, it could be a metal screen, or it could be paper media or a cartridge filter, and they might rate it by mesh. I live in microns. So we like the physical attributes of knowing what size our particles are in microns. And again, to give a shout out to Paul Fisher, his group, and folks that have been working with him, and now many of them are on their own. They tested a lot of greenhouses and nurseries, and they found, and I just thought this was an interesting number, that 150 microns was the median size of those suspended solids. Now that's probably a floriculture or ornamental greenhouse. So just keep that in mind. That's 150 microns. And you can see where that fits. These are some determinations. These are sort of the Les Evans these are definitely not anybody else's terms other than just trying to separate them. A lot of coarse filters do a great job at fine filtration. A lot of fine filters can get into the ultrafine, but these are just some good broad understandings of what I'm talking about. The mesh numbers, by the way, in parentheses, mean that doesn't exist. We can't get down that fine with a physical mesh, and we start talking about membrane filtration in the ultrafine. So again, I just wanted to make sure we looked at this and understood the sizes of certain things and examples of what we're trying to filter. Typical silt, you can see around 30 to 40 microns. And our friend Phytophthora and its zoospores down 7 to 10, and so on. So here we go into the filter types. We have coarse, fine, and ultrafine. Under the coarse filter designation, there are hundreds. Under each of these, there are lots. These are the big ones that we see in our industry. I know I'm leaving some out. I'll talk about some in more detail coming up. Slow sand filtration is the most common outdoor nursery. Agriculture used to use a lot of slow sand filtration. While it is slow, I hardly ever end up recommending it for any of our CEA facilities. It takes a lot of square footage to do a job, and it's just not as precise as I'd like to see it. But again, it certainly has its place. We'll talk about some very simple gravity screen, or otherwise known as bow filters, for getting out our coarse debris. Some moving media filters. There's several flavors of those, paper being one of the more common ones. Rotating drum that comes from other industries we see as well. So we'll take a look at those. Fine filtration, a couple of flavors of those as well. Moving media creeps into there very well. We'll talk about deep media filters. And then membrane filtration is what we're talking about when I am talking about ultrafine filter types. So filter efficiency, I'll go through this quickly. Just be aware when you are talking to, well, me, and I hand you a piece of literature on a filter, or you pick one up at a trade show, that you understand if somebody's telling you how efficient a filter is. Ask other people too, because it's probably done in a lab, it's probably done brand new. And yes, a filter might be able to remove down to 10 or 20 microns, but it's allowing 1,000 micron particles through. So it can be kind of tricky to navigate what we're telling you a filter can do and what it's really going to do for you. I just want to point that out. Anybody, industry experts that have been around and the researchers that look at this very closely are certainly going to make you just, hey, buyer beware a little bit, but you come across folks that really want to help you, and we'll make sure that we walk you through what that means for your situation. This one, again, shout out to the same researchers, Paul and his group. Just did some really fascinating, eye-opening studies for me. I had been selling paper media filters to some of the largest growers in the world. They were very efficient to a point, and they just, yes, this paper is rated to X, to 20 micron, 50 micron, but it had openings, just huge openings. So it was filtering out, 50% of those 50 micron particles, and therefore being successful in that. But again, filter efficiency, what does it mean? What does it mean for you? Buyer beware. Enough about that. So coarse filtration, it could be 10,000 microns down to wherever you want to stop. But this is one of those cascade bow filters, does a very good job. It's almost always a primary filter in a recirculating system. It doesn't necessarily need to be backwashed, so there's no backwash water to remove. That's a positive. It's removing very big chunks, and you physically drop it into a trash can or barrel and haul it off. And so that's a positive of what it does. Again, it's depending on what screen you've got and what model and make you have, it's going to be only so good at what it states it's going to do over time, especially. So that is a well-known filter. This is a little newer on the scene. It is a rotating drum filter, came from the aquaculture. It is having to constantly wash itself down and therefore has a constant backwash that you need to take care of. So unless you've got a large pond or sediment retention basins, this might not be it. And it's obviously really meant for larger flows. Some of these others can be used for small flow rates. Here's the paper filter in question, still popular. Paper is a consumable. Be aware of what it's doing as far as that micron size opening. It can move about 100 gallons to 900 gallons per minute off the shelf. So it's good at high flow rates. There's no backwash solution to get rid of, so to speak, but you've got a lot of paper now that you basically have to send to the dump. So just again, those are some popular coarse filtration options. Getting into the finer filtration, these are screen or cartridge filters. These might look familiar to you. Many of them are auto backwashing because it will require that you flush them out with water. Again, what are we going to do with that backwash? Might be no problem to dump it down the drain. We will help you calculate, or whoever you're working with, I should say, will help calculate what that backwash volume might look like. And so you can determine how to get rid of it. We've got varying sizes and really a huge flow rate. Some of these larger, higher flow rate self-backwashing filters can be seen on very large operations. And then we have really neat, small, tiny ones for a lot of our indoor growers or smaller growers. So again, these are all part of the potential filter. You might have a coarse filter in front of a finer filtration. That is very, very common. And I want to point that out as well, that we are not ever talking about a magic bullet filter to take care of all of your problems. There's going to be a best next step to take care of that problem or on the way to taking care of their problem, but there's never a magic one. A bag filter, sort of making a comeback. This is something that, again, there's no backwash. So if you are in a state or area which will prohibit you dumping a backwashed solution of dirty water down the drain, then again, one of these screen filters, these have removable cartridges that you would clean out, but also require backwashing. These do not require backwashing. You throw this bag filter away essentially, but they can be anywhere from about 500 down to 5 microns. About 20, 25 microns, depending on your eyesight, is microscopic. Anything under about 20, 25 microns, to give you an idea, is microscopic. So again, bag filters can do a really good job, but you don't want to have to change this out every day. High load, high organic matter. You've really got to stay on top of this maintenance-wise, due to the fact that it's not going to magically clean that bag filter for you. These 3 filters all look exactly the same, don't they? These are depth media filters, and these are the workhorse for most treatment companies within our industry because of their flexibility. These 3 filters are tackling 3 very different problems. This first one is a screenshot of a project done in the last couple of years that was removing very high irons. It has a media of green sand that we're injecting potassium permanganate in. So again, iron levels typically over pretty small parts per million are detrimental to our crops, and we need to get rid of it. This was well water, and we are removing iron at high levels, medium levels, and low levels very efficiently with a green sand media within this blue vessel. And it requires some regeneration to make sure that the ion exchange happens and we can remove that iron efficiently. The same exact looking pair of filters is removing chlorine. High levels of chlorine, undesirable, especially for really young plants. I believe this one was maybe a leafy green, baby green facility, indoor facility. Just wanted to make sure we remove chlorine. I'll talk about reverse osmosis in a minute. Everybody thinks they need RO in some industries. We do not. Maybe a simple granular activated carbon filter is going to take care of our chlorine removal, if that's all we need to do. Chlorine is something that's quite easily removed by an efficient, properly sized media filter, and that media being granular activated carbon. We can remove really tricky things, help remove things, growth regulators on a recirculating system, that's paclobutrazol, piccolo, something like that. If we're recirculating or needing to capture it or even remove it before we dispose of our water into a sewer system. Again, activated carbon is becoming something that's really being studied more and can take care of a lot of issues. Algae and sediment, this project these are pre-filters before we dump into a large storage tank. It's pond water. So what we've got inside there is pretty basic, either a crushed glass, some sort of sand, zeolite, pebbles, getting rid of those physical particulates very, very efficiently. You'll notice the plumbing on all three of these. First of all, there's a set of two. Many of these filters, you can have one inline or multiple inline, and that's so we can always be treating water even when we're back flushing one of the filters. So a minimum recommended typically is 2 filters. We see the little boxes on top of them. Those are timers or digital timers. We can keep pretty basic and just, hey, we think we'll need to back flush every night. Let's set the timer to back flush. We know very precisely how much water is used per back flush cycle on these. That's another reason we like them. And we're able to understand exactly how long that media will last. Some of them last a very long time. Others, like the activated carbon rule of thumb based on use, of course, is between 9 and 15 months. We might need to replace that carbon in the carbon filter. So again, these are examples of fine filtration. Flow rates of 5 gallons a minute up to 5,000 gallons a minute based on how we need to tackle that. Ultrafine membrane filtration. This is reverse osmosis. This is a nanofiltration. This is getting rid of pretty much everything, and it gets rid of a lot of what we don't need to get rid of sometimes. I spend more time talking people out of purchasing a reverse osmosis system than I do talking them into it. So it's something that is the necessary evil. We really want to make sure that if we do have to use it, and it's almost always a high salts situation where I would have to recommend this, if there's no other way to tackle it. So that's where reverse osmosis is, again, is something that we just are going to have to bite the bullet and invest in. It's typically very expensive per gallon produced, and it requires, I should have shown a picture, but it's going to require a lot of pre-filtration, like an activated carbon filter to get rid of chlorine so we don't destroy the membranes, which are very sensitive within the reverse osmosis system. Larger systems are going to require a clean in place injection system. So this is a very technical piece of equipment, been around forever, does a wonderful job at what it does, but it has a lot of things we need to be aware of if we are going to go down that road. So we have a lot of permeate, a lot of water that's coming out of that, which is obviously very salty water if it's salts that we're removing. We can blend it back in almost always. Very rare that we would use pure RO water on a crop. So we can blend it back into the raw water to make sure we make that investment as efficient as we can and get the most use out of the water it's treating. So again, it's something that we certainly talk about every day, but it's really a very specific piece of equipment to tackle what is almost always a high salts issue. So going to the location of any of these filters, this is just a representative. There's some media filters on the left to represent a centralized system. And on the right, we have a very simple cartridge filter that if you are working with any irrigation company that's been around a while, they should be putting one of these very simple zonal or zone-based distributed filter systems. Now it's just got a cartridge in there, 50 to 100 microns, and it's protecting what might have fallen off between a centralized system and your micro irrigation system or misting system. So the answer is most often both. We're going to be putting filters, looking at purchasing the most efficient filter we can, or set of filters or groups of filters in a centralized location. Again, thinking about storage, and I'm going to talk about that again and again and again, but then we're moving that water to zones to grow our plants. Let's talk about zonal filtration as well to capture anything that's come off within the pipes. We do need to obviously be checking this manually, put that on your maintenance list. So I want to make sure that we understand that it's almost always a great combination of a centralized filter system and one that's been distributed. This looks complicated. It is a water room in a greenhouse. It could be growing anything. I'm not going to say it's cookie cutter, but it is basically a complete treatment system. And look at that giant tank. So we are able to store water and treat it again at a slow rate to have minimized the sizes of the filters around it. They might need 250 gallons per minute at any given time to do what they need to do out in their vertical warehouse facility or nursery or greenhouse facility. But our filtration is only needing to work at 20 gallons a minute because we are refilling this tank at an appropriate level, so we are able to average those flows. You'll see multiple blue vessels in there representing different flavors of filters, pre-filters and post-filters. This particular site, by looking at this project drawing, I can tell that white medium-sized tank in front of the large storage tank is actually filtering the backwash water. So they were having to pay to ship off their backwash solution. And so we're using the settling tank essentially to get rid of all the moisture we can and just get rid of those solids, turn it into a muck instead of a watery solution to save money on getting rid of that backwash solution. So pretty rare, but if you have to do it, there's certainly good, smart ways to do that. So that's really wrapping up the technical side of it. And again, we want to make sure that we are looking at everything we can to make the best investment. We can't recommend something you can't afford or won't be able to afford, considering your budget. For all of these things I've discussed about, Al and I don't have my MBA, but I feel like I do sometimes as we guide growers through their next investment or building a new facility. We really take a hard look at making sure you're around next year, in 5 years, and 10 years. And is this going to make sense? So filters are sort of considered risk management. We are having to remove potential hazards, but also have that pay for itself. So the filters I've talked about can be sized. You could size, I'm going to be this big in 5 years. I want to buy everything I need now to be where I need to be in 5 years. I might slow you down and say, hey, these filters are really modular. Let's stage it appropriately. Good filtration will also allow you to pay appropriately and not be paying for more chemicals, more sanitizing agents. If you are properly making an investment now, you will not have to pay that ongoing cost of injecting an expensive chemical, for example. Know your water. I hope I've presented some aspects of water quality, of what might be in your water. We have lots of labs that we use depending on what we're looking for. Get an analysis. Even if you are in the middle of a big city and it's obviously healthy water, I will still require that you send off a sample of your fancy city water to get an analysis so we really understand what's in it. and what might happen when we inject nutrients. So there's also something to consider. Know your enemy, and make sure that you understand what might be in that water. And as I've mentioned, there's almost never one perfect filter solution that will take care of all of your problems. There's going to be that next best filter decision, and it might take care of 90% of your problems, but we'll hopefully be very understanding of, listen, this is going to take care of this particular problem, but you'll still have this, but let's wait a year or two to take that investment. So there's almost always a good next step, hopefully, a very good next step, but not one magical step filter type solution that's going to last you forever and do everything for you. Get out there, talk to other growers. Some industries are much more talkative than others and much more willing to share information. We're aware of that. Companies like ourselves, there's lots of good industry experts out there that are going to give you hopefully a very good understanding of what you should be looking at investing in and when. So those are just some really good advice. Maintain your equipment. Dramm manufactures a lot of different things. So again, Al and I sit in the water division, but of course we make sprayers for chemical application, pesticides. Maintain your equipment. It's just fascinating to see somebody buying a very expensive piece of equipment and then not treating it well. So you're going to hear that from anybody you talk to at Dramm, no matter what you buy, if it's a hose or if it's a expensive water treatment system or a $2 cartridge filter, maintain it. So again, more just, there's the cartridge filter on the left, you know, $5 to replace it. Make sure you're doing that. And water treatment, photograph of a project on the right. These are both filter systems. There is one that will make sense for your facility. So make sure you choose the right one now, and make sure you're always monitoring and testing water qualities before, during, and after any of these system investments to make sure that it's doing what it was stated to be done. And so that is the end of the presentation. These are the sort of, I just say, credits and resources that I really like. Water Education Alliance, there's Dr. Paul Fisher, Dr. Sarah White, Dr. Rosa Rodelis was under Paul Fisher and now at the University of Connecticut, helps with the Clean Water 3 website. So just some really neat information there that you can access. And then I'll mention, of course, Al's discussion coming up on July 24th. And I think I am done, Karen.
Great. We have a few questions here. First of all, and I think this is probably from a Purdy's girl, for a recirculating hydroponic system, is there one filter type that's best?
For hydroponic system, is there one filter that I would recommend? Was that the end of that question?
Yes.
Wow, yeah, that's one of my typical conversations, I guess, during any given day, because hydroponics especially has really been something that we have worked with more and more. Every year that passes, we're really probably exponentially getting more of those types of growers, which is a lot of fun for us because yes, we are, as an environmental water soil guy, I love recirculating the water. There is not one magical filter that we would just pull off the shelf. Oh, you're a hydroponic grower? Here, you want this filter, and plop it and sell it to you. It's a conversation. We're going to look at exactly what you're growing, the nutrients you're putting into it, the source water that we're topping off this hydroponic system with, what kind of storage you've got. The media that you use is a big one. It could be a soil-based media, which most of the organic hydroponic growers are having to use. So that's a very different filter system layout than would be a really traditional NFT rock wool, much cleaner, I'll call it, using synthetic fertilizer type system. So those are, again, that's a great question, but the answer is basically no. That's a bigger conversation.
So speaking of media, Can you replace older media in your current sand filter with newer media like the ones you mentioned? And would this improve filtration?
Oh, very good question. I don't think I mentioned that. In most all of the deep media filters, yes. Even if you have an older slow sand filter, we can make calculations and replace the old silica sand, which is typically basically cubes that end up over time stacking on each other, making that filter a lot less efficient, a lot harder to backwash. There's just newer media, as I explained, that we can actually put into an older vessel. So the flexibility is really great. If you've already invested in those vessels and the piping and the plumbing and the hopefully backwashing equipment of those, then there are probably some really next choice medias that we can use that are going to just be a little bit better, probably getting down to a finer particle size, filtration, as well as back flushing a lot better. That's a great question. I don't think I mentioned that. And even if you have other types of filters, a screen filter, you can upgrade it to a finer mesh, but you'll have to make sure it stays clean. That might require backwashing more frequently. Or if it's not a backwashing screen or cartridge filter, you're gonna have to check it every day, for example, instead of every week. So yeah, great question.
All right, we've got one here on misting nozzles. I have filters, but my misting nozzles still clog. Why?
That's a good, very open-ended question. Could be a number of things. Would need to know what is clogging that mister nozzle. It could be, if you remember the slide, chemical, biological, or physical, or probably a combination of two or maybe three of those. So we'll take a hard look at it and analyze it. That would be, if it's a hard, crusty precipitate, that means you might be precipitating out irons or hardness, and that's a clogging issue. If it's a wonderful, snotty, discolored, weird goo, that sounds like a biological issue. So we would want to take a look at exactly what is clogging those mist nozzles and work our way backward and make sure that we are choosing the appropriate filter for what we're trying to filter, stating the obvious. But that is a good question, and again, a filter could be anything from a cheesecloth to one of the, a reverse osmosis. So we really have to make sure we're looking at what's going to make the most sense for removing whatever is clogging that nozzle.
Alrighty, we have one last question here. Is one filter on the incoming line of my greenhouse enough to keep my drippers clean?
Yeah, similar, same question, similar, same answer. It might be, but we'd have to take a look at what kind of filter that is. Again, some of the newer indoor industries, there's lots of filters out there that are trying to tackle a lot of things with just one off-the-shelf solution. So again, we start at the plant. Let's focus on what are we growing, how are we irrigating it, and I'm working my way backwards from the plant to the to the pumping system, to the water room, to the source, and I need to understand what filter is going to take care of getting the appropriate irrigation to that plant. So again, a similar answer is maybe, but that requires a bigger discussion, and looking at the water quality and what you're injecting into the water to help grow that plant. So
sounds like there's really no one size fits all. It really is a case by case, and that's something that you and the others in Dramm can help with.
Yeah, absolutely. That's what this water division was born to do. We really enjoy doing it. Two facilities side by side, growing the same thing, have different issues. It's fascinating. So it really is a lot of fun discussions with our growers. on what they're trying to accomplish, and we want to make sure it makes business sense. We can sell you equipment all day long, but if you're not there in a year, that's done nobody any good at all. We really hope we are able to partner with whoever we work with. So yeah, Dramm is not we don't just have a filter. We don't just sell one kind of water treatment. We've got this arsenal of really smart people and excellent vendors behind us, and we can bring just a giant variance of solutions to the problem. So that's what's most fun about it, is always researching and always discovering a new problem we haven't worked with. Well, we're going to pull in some folks. If we don't know the answer, we will find folks that can help us get there based on your problems and what's going to make the most sense.